Welcome back. Today we're going to be talking about introducing quadratic functions. Let's go ahead and take a look at some important information. So here you can see we've got the three graphs that we've discussed this year: linear, quadratic, and exponential. Linear is going to make a straight line using the equation y equals mx plus b. Exponential, y equals a times b raised to the x power plus h, is going to give us that curve. And then quadratic, that we talked about last unit and we're talking about more today, is y equals ax squared plus bx plus c, and that's going to create a parabola. Now that we've seen the differences on graphs, let's go ahead and see the differences on tables. So here we've got three tables that apply to each of the different types of equations that we've talked about: linear, exponential, and quadratic. So I can see that my linear graph has a linear change. Whatever happens is going to happen the same every time. So here I'm going to be adding 4, 4 to 8 is adding 4, 8 to 12 is adding 4, etc. Exponential, my graph is going to go up exponentially. I'm going to raise 2 to the negative second. That's going to give me 1/4. To the negative first is 1/2. 0 to 1, 1 to 2, 2 to 4. So it's going to increase exponentially. The quadratic is slightly different though. When you type in a quadratic, you're going to end up with points that are going to be the same, or at least you're going to have values that are the same as y, because you're going to be creating that parabola. Remember, you're going to be creating that curve. So we can see that happen here when our y value is 4 twice, and that's because we have that curve that's come around. Now let's compare these in real-world examples. So here we have two real-world scenarios, one for a linear function and the other one for quadratic. So in our linear function, a puppy weighs 12 pounds at 4 weeks and 20 pounds at 16 weeks. How much did the puppy weigh at birth? So we can see here that the puppy's gone 0 pounds, it's gone 8, so it's added 4, then it's 12, it added 4, 16, it added 4, 30, it added 4. All right, so you can see that the weight is continuing to increase every week. Our quadratic says that fireworks are set off upwards from the deck 7 feet off the ground, and when the fireworks reach the maximum height. So this question is trying to tell us where are we going to find the top where our fireworks go up, and then gravity affects our fireworks and they come back down. So we can see that's going to happen here at the maximum, right here at the top, and that is our point, and we can see it also in the graph at 2:30, because that's when our fireworks start to go up and then come back down. Now let's go ahead and take a look at more information about the parabola. So here we can see the characteristics of our parabola. So a parabola has an axis of symmetry, also known as the line of symmetry, and this divides the parabola into two equal parts. To find without a graph, you would take negative b and divide that by 2a. If you see your graph, you're going to just draw a straight line down from your vertex. The x-intercepts are also known as solutions, roots, or intercepts. They all have different names, and that's where the parabola crosses the x-axis. And then the vertex is the turning point, the minimum or the maximum in the graph. If the graph is at the bottom, then you're going to have a minimum. If the vertex is at the top, then you're going to have a maximum. Let's talk more about that now. So here we are identifying the parts of the graph and to fill in the answer for each box. So the first thing we need to do is identify the domain. Remember, the domain is the set of all x values, so we're trying to figure out where is this parabola going to fall on the x values. And we can see that the parabola is going to continue to go up and out forever, both left and right. So it's going to cover all of those numbers. So for that purpose, we're going to have all real numbers or fancy R, depending on how you look at it. Then we're going to take a look at the range, and the range is going to be set because while it does go up forever, it doesn't go down forever because it has a stopping point right here at the bottom or the vertex of our graph. We can see that it's not going to go any lower than -2. So our range we know is going to go between -2 and +infinity because it is going to go up and out forever, but it's never going to go down below -2. Then we have to take a look at our solutions. Remember, our solutions are also known as our x values. They're also known as the roots of our function, whatever you want to be calling them here. This is where our parabola is going to be crossing the x-axis. In this case, it crosses at two places, here at 2.5 and here at 1/2. So what are our solutions? Well, we're going to write them using our braces, and we have -1/2 as one of our solutions. Don't forget your negative sign. And the other solution is going to be 2.5. But we're always going to write that as a fraction. So that's going to be 5/2 here, and then close your braces. All right, then we've got ourselves our vertex, which we located earlier when we were talking about finding the range here. What was the lowest point in our graph and where does it turn around? And it turns around here at -2. All right, so our vertex is at -2 for our y value, but what is our x value? It's at +1, so +1, -2. Then we're going to talk about our line asymmetry. So where does that line go straight down from the vertex? So in this case, I'm going to draw that line right here through the vertex. And that line, remember when we have a vertical lines are always written as x equals. So in this case, x equals 1. And then we have to determine, do we have a minimum or a maximum? Well, in this case, the graph can go no lower than -2. That's the minimum it can reach. It can go up forever, so it has an unlimited maximum, but it only has a limited minimum of -2, so minimum is what we have for this graph. Let's take a look at another example. So here is another graph, and we can see that our parabola this time is facing the opposite direction. So let's see what that changes. So in this case, we're going to be talking about the domain first, but we can see that that graph is going to continue to go out to the left and out to the right forever. Even though it's going down, it's still going out to the left, right, and left forever and right forever. So therefore, our domain is again all real numbers, or fancy R. Our range, however, not so much. It does go down forever, so we know we've got a range of at least -infinity because it is going to go down forever. However, it does have a stopping point. It goes no higher than this point here, which is 6. So our range ranges between -infinity and 6. Now we've got to look for solutions, which again are going to be the roots or our x value. So where does it cross? In this case, we're going to be crossing the x-axis here and crossing the x-axis here. So we're going to write both those down again in our braces. Looks like we have -1/2, or we're going to write that as -3/2 because we're going to write that as a fraction. Then we can see there we have 5.5, but again, we're going to write that as a fraction. And for us, that's going to be 11/2, and then we're going to close our braces. Now we need to identify our vertex. So again, that's the point where our parabola turns around. In this case, it's going to be at 2, +6. Our axis of symmetry is going to be that line. So where is it going to go through that vertex? So we're going to draw a line through the vertex here. And again, remember our straight lines that are vertical are going to be x equals. So in this case, x equals 2. And then we've got to determine, do we have a minimum or a maximum? So our graph can't go any lower. It's going down towards infinity. But when it goes up, it stops at 6. So we have a maximum value of this case of 6, where we can go no higher than. Now let's go ahead and take a look at another example. Here we're going to be evaluating the quadratic function using our graph. So we've got f of x equals x squared plus 3, and it wants us to find f of 0, f of 1, and then find f of x equals 4. So let's start with f of 0. So when we're using our graph, we're going to first determine, are we finding our input or our outputs? In this case, 0 is inside our parentheses, so that should indicate that we are looking for the input. So we're looking for when x is 0. So when we see when x is 0, we can see that this point here is on our graph. So that is at 0, 3. So we know that when f is 0, we know that that's going to be equal to 3. So f of 0 is equal to 3. Now we've got to find f of 1. So again, 1 is inside our parentheses, so that's indicating to me that it is the input. So we've got to determine where f is for our graph for 1. So our x value of 1 is right here. So that's going to indicate that we are at 4. So when we write that, that's going to be f of 1 is equal to 4. Now it gets a little trickier here at the end because we've got f of x is equal to 4. And this time we've got 4 outside of the parentheses. So that means that we're looking for the output. So we're looking for when y equals 4. So when y equals 4 is this line here. So we want to know whenever anything on that line crosses the parabola. So in this case, we've got one of them already. We've highlighted that when we found f of 1. But in this case, we also have another value, which is over here at -1, also crosses. So we've got 2 values there, and we know that because this is a parabola. So we're usually going to have 2 solutions. We'll talk about later when we don't have 2 solutions. But in this case, when f of x equals 4, that means that x is going to equal 1 and x is going to equal -1. Now let's see what to do if we don't have a graph. Here it wants us to evaluate the quadratic function using the equation below. F of x equals x squared plus 5x plus 9, and we've got to find f of 2 in 2 inside the parentheses and find f of -3. So let's start with f of 2. So again, it's very important to determine, do we have the input or we have the output? We can see the 2 is inside the parentheses. That indicates that it is our x value that we've been given. So when that's the case, we need to make sure that we replace all of our values with that number that are x. So in this case, I have f of x, that's not an x value, that stands for y, equals x squared. In this case, again, I'm going to use parentheses to substitute, 2 squared plus 5. Again, I have to substitute the x there for 2 plus 9. So notice that with a quadratic, I have to substitute that number in twice. Usually we only have to substitute it in once because we only have one x value. But in this case, we have two x values, so we got to make sure that we substitute it in twice. Then we're going to just use our order of operations that we've used since 5th grade with PEMDAS or GEMDAS or GEMS, wherever you learn that. So 2 squared is going to be 4. 5 times 2 is going to be 10, and then plus 9, and then you're just going to add all those values together. And when you do that, you get f of x is equal to 23. So 23 is our answer for the first one. The second one, again, I've got f of negative 3, so I've got to make sure that I substitute that value in for all of my x's, and I know it's my x because it's inside my parentheses. So I'm going to again use my parentheses here for x, nope, not x squared, negative 3 squared, because that's what we're replacing x with. So negative 3 squared plus 5 times negative 3 plus 9. Now again, it's very important that you use parentheses when substituting. If you don't do that, your calculator is going to give you the incorrect thing when you take negative 3 and square it. You want to make sure that it's squaring negative 3, not squaring negative parentheses 3 squared. So make sure you're using parentheses correctly. When you do that, negative 3 squared is going to give you 9. 5 times negative 3 is going to give you negative 15. And bring down your positive 9. Now again, you're going to use your order of operations here where you're going to go adding. You can use your Decimalist calculator. And when you do that, you should get f of x is going to be equal to 3. And so therefore, we know that 3 is the answer to our second problem. And that brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub. And we will catch you in the next one.